In today's video, we are going to be breaking down the difference quotient formula. So if this is something you're struggling with or are interested in, keep watching. Let's say we had the graph of a parabola, and let's say we had this line that cuts through this parabola. Now there's a name that we call this specific line, and we would call this line a secant line. And a secant line is a line that crosses through two or more points. And as you see, this line is crossing through 2 points on this parabola. Now let's say we wanted to calculate the slope of this secant line. Now of course, to calculate the slope, we can use our slope formula, y2 minus y1 all over x2 minus x1. So we can say this first point right here is x1, y1, and we can say this second point right here is x2, y2. Now what we're going to do is we're going to do a little substitution, okay? So for our first point, x1, y1, instead of calling it x1, y1, we can say that this is the same thing as x, f of x, right? They're both interchangeable, they mean the same thing. And we can also say that these 2 points are a distance away from each other. And let's call that distance h. So they're h away from each other. We don't know what that value is, but we're going to call it h for now, okay? Now for our second point, x2, y2, instead of calling it x2, y2, well, since the second point is h away from the first point, we can say, well, this is x plus h, comma, f of x plus h, okay? So now that we've done a little substitution, we can now plug it into our slope formula. So our y2 is f of x plus h, and our y1 is f of x, right? And then our x2 is x plus h, and then our x1 is x. So when we plug it in, we get f of x plus h minus f of x all over x plus h minus x. Now we can actually clean up the denominator because we have x plus h minus x. Those x's will actually cancel out, and that'll leave us with just h. And when we fully simplify this, we get our final slope being f of x plus h minus f of x all over h. And this may look familiar because this is actually our difference quotient formula. So as you see, our difference quotient formula is actually derived from our slope formula. And you can probably argue that it is our slope formula, it's just represented in a different way because we just did a little substitution, but they're both pretty much the same, right? Because we just plugged these points into our slope formula just to land at this value. Now you may ask, why did we do all of this just to land at a different way of representing our slope formula? Why did we substitute our x1 and y1 and our x2 and y2 with x and f of x and x plus h and f of x plus h? Why did we do all this? Now, this difference quotient formula actually plays a very, very critical role in one of the big topics in calculus called derivatives. And this formula plays a big role in calculating the derivative. So there is a method to this madness. Now we're not going to be going over that today because that's just a whole other can of worms. But there is a reasoning to why we did all this substitution mess, okay? Now, I want to put a disclaimer that yes, we did all of this just to calculate the slope of the secant line, and the difference quotient is basically how you would calculate the slope of a secant line. This represents the slope of the secant line, but I also do want to say you could have very much used the normal slope formula, y2 minus y1 all over x2 minus x1 to calculate the slope of the secant line as well. But like I said, this difference quotient formula right here does have more of a purpose when it comes to calculating derivatives. But that pretty much wraps up this video, guys. That is where the difference quotient formula comes from. The difference quotient basically defines the slope of the secant line. But of course, you don't have to use this formula to find the slope of the secant line. You can use either or. You can use the normal slope formula, or you can use this fancy difference quotient. But that pretty much wraps up this video, guys. I hope this was helpful, and take care.